All right. I want to start here on page 9 with this idea. Can you do these two logarithms? Log base 2 of 4 plus log base 2 of 8. Now, I know there's a plus sign here, okay? But what I want to do is look at these individually. And remember, you can use these papers on the cabinet to help you, right? Here's how. Here, remember, it is 2 to what power equals 4? Scarlett, what do you think? 2 to what power is 4?
The second.
So that means the answer for log base 2 of 4 is also that same answer, 2. I'm going to carry down the plus sign here. Carson, log base 2 of 8. Any thoughts on what that might be? 3. It is 3. Remember, 2 to what power is 8? Good job, Carson. It is 3. Thank you, Maren, for having that. Now, here's the difference today. With what we're going to see today, part of what we're going to see is using having a plus or minus sign in between the logs. Now, that's what we have here. On this, what would my answer be if I actually just added those together? 2 plus 3 is
5.
We're on page 9.
Actually, no, it's cookie.
It would just be 5, right? Here's really what I'm trying to get at. If my answer here is 5, what would this number have to be in the circle to make it 5 right here? If I added them together to make 5, what would this number have to be in the circle? Wouldn't it have to be 32? Students, think about what I just did. 2 to this time, I know the number. Isn't it 2 to the 5th power equals that number? Isn't this 32? Here's what I want to do. These numbers in purple, or what I've circled in purple, what is the connection between those numbers?
It's multiplication.
It's multiplication, right?
I used that as a quick.
Oh my goodness!
I used that as a quick term when I did my 8F assignment until you blocked it.
Anytime that we see a plus sign between two numbers, I'm going to multiply the two arguments. If I see an argument of 4 and an argument of 8, I'm going to multiply them to make 32. Caleb?
So like if it's subtraction, is that division?
Let's get to it. When I see this idea right here, this is what we just explored. Anytime I see two logs, now let's make it clear. The logs must have the same base. Do they have the same base here on this problem? They do. We are not going to this year see anything that says log base 2, log base 7, right? That's not something that we're going to see this year. You might see it in future years. We can argue about it then, okay? If you need some help on that, happy to help come back and we can chat about that. But we're not going to see it right here. The only idea that I want us to know is if there's a plus sign, I'm just going to multiply them together. And maybe not to you, but to me that makes sense. Isn't just successive addition really multiplication? Right? So they kind of have that connection between it. Now, Caleb, you asked a different question. What do I do if I see a minus sign? What do?
Divide.
I would divide them. Division is really successive subtraction, right? One way to think about that. And that's what these are showing right here. If I see a plus sign, I'm going to take the two arguments and I'm going to multiply them together. If I see a division, or excuse me, a subtraction sign, I'm going to take the two arguments and I'm going to divide them right here, right? This last one, this is called the power property. If I see a number connected by multiplication, it's really the exponent of the argument. Okay? Now these ideas will come into play a little bit later, right? But this is what we're taking a look at. Now there's a couple other words I want us to be mindful of. The words expand the logarithm or simplify/condense the logarithm. If I am starting with a plus or minus sign, I will be condensing the logarithm going this way. That means I will see addition and make it multiplication. I will see subtraction and I will make it division. I will see a number directly in front of the log and I will make it the exponent. The other way we could see this is I could expand. Expand the logarithm goes the other direction. What I mean by that is, if I see multiplication, I'm going to insert an addition in there. Notice there's two different logs, right? If I see a division, I could write both of the logs with a minus sign there. And this idea right here really is just an exponent going to the multiplication. Now here's where this all kind of connected. When I was looking at this right here and the division, I was thinking about this as negative exponents. Students, if I see a negative exponent, what happens to that number? It goes to the bottom of the fraction, right? If I see this right here, isn't it really like a -1 in front? Which means the number is really a negative like this, which goes as the exponent. Doesn't that make sense? If this purple circle is negative, wouldn't it be on the bottom of the fraction? Right? Making that connection together. So all of these things are still happening right here with ideas about exponents. Another word that you could see, instead of condense, it might just say simplify. Okay? So that's just another word we could see about that. But let's back out a little bit here and let's take a look at example 1.
It's easy. You divide 32 by 2 and then you get 16.
What do we see? Product? Quotient? Power?
Quotient.
Damien, what do you think? Sure. I'm looking at this question here. Do you think I'm going to be using a product, a quotient, or a power property? What does that mean? What am I going to do with the two arguments? I'm just going to divide it. Log base 4 of 32 over 2.
32 over 2. Oh, okay.
Now, students, if I can simplify, don't I want to do that? Log base 4 of 16. Maddie, what's my final answer?
4 raised
So what's my answer? Not to the second power, just 2, right? Students, anytime that I want to do this, I might say, okay, 4 to what power is 16? I'm looking at the salmon papers on the cabinets. What row is 16 on? That means 4 to the second power is 16. My answer is just 2. Do not put your answer as an exponent. Your answer is a regular size number. Okay? Let's take a look here at C. Try letter C on your own. Try letter C here on your own. Has to be 4, right? But Sydney, what two things am I going to, what does the plus sign mean again? What two things am I going to multiply together?
5x and 3x.
Is,
15x
keep going,
squared.
15x squared, right? The numbers, or in this case letters that we multiply, we're still multiplying them like normal, right? 5x times 3x back in middle school was 15x squared. Same thing right here, right? We just have the logs with it here. Sometimes on B and D we might see multiple steps. Here are the three properties. KJ, what do you think? Do I see anything that indicates I would be using the product property here?
Addition.
Yep, I see the plus sign, right? So I know I'm going to use that. I'll come back to it. Allie, what about the quotient? Anything here on letter B that I'd be using the quotient for? I agree, there's no minus sign, right? So, not using the quotient right there. What about the power property? Remember, a power property means that there's something directly in front of the log connected by a multiplication. Noah, yay or nay? Yeah. Yay! What would I do first? Order of operations, the one that deals with multiplication or the one that deals with exponents? I do the one with exponents, right? So, students, log base 2 of x to the 6th power. I saw the number in front and I just wrote it as the exponent there. Can you do the second one, please? Brooklyn, not that you have to have the answer now, but when you're ready, I'd love to hear what you have using the power property to that second one. That's exactly right. Log base 2 of y to the 5th power. That's perfect. We just did the power property, right? Now it's time for the product. Oops. Well, I know it has log base 2. Dylan, I had a plus sign, so what do I do with these two variables here? Not add them. Notice right here, I didn't take 5 plus 3 to make 15. I multiplied them, right? So I have x to the 6th multiplied by y to the 5th. X to the 6th times y to the 5th. That is my final answer there. See if you can come up with letter D. Take a minute or two. Try letter D. So there's the answer for letter D. Thank you, sir. All right, let's go the other direction now. The other direction says, hey, what if now instead of condensing, I'm going to be expanding? So the idea with this is we're just doing the opposite. So I'm going to look at the product, the quotient, and the power. Do I see any exponents here on this problem? No. So we're not going to be using the power property. What am I going to put between every single multiplication problem if I'm expanding it? Excuse me, I'm going to put an addition sign, right? So it looks like there are two things that are connected by multiplication. It's 4 and x. So I'm going to have these two logs, and am I not going to put a plus sign between them? Real quickly, students, what number am I circling right here? What number did I just circle?
That's the base.
What is the base of every log that you don't see, every LOG log? 10, right? I'm circling the number 10, just so we're on the same page. Well, what would have to go between these two logs right here? What's between the x and the y? Isn't it a division sign, so I need subtraction right there? Students, I want to ask you this question. I'm going to write two of them up here, and I want you to help me decide which one of these is accurate. Okay? So I'm going to write the answer, and you decide, is it the top one or the bottom one? Here are the two options right here. Which one is the correct answer? Is it, now it's not, I'm freezing. Is it the top one, or, what happened there?
Oh.
Yep, there it is. Is it the top one or the bottom one? Which one shows the correct answer right here? The difference is one of these has a 4 in front of both logs, while the other one, it's just in the front. Okay? Here's my question. Is it both of the numbers to the 4th power, or is it just x to the 4th power? It's just x to the 4th power. So this one right here, students, goes right here. If you wanted to see if this would have been the right answer, it would have looked like this. See how both of them are to the 4th power right here on this one? That's how it would look if this one was the correct answer. Okay? So keep in mind, exponents are important. They do affect where the number actually goes. All right, let's mosey on here to page 10. If we're looking at page 10, let's just try a couple more. I have this log base 3, means I need 2 of them. Samantha, what do you think? What sign goes between these two logs? Addition, subtraction, or an exponent sign? Say that again? Not addition. We see division right here, right? So which symbol most closely resembles division? Subtraction, right? This would be the right answer. Same thing here, students, for letter D. Okay? Which one of the following answers is the correct answer right here? I have 2 right here. Which one of these is the correct answer? Is it topsies or bottomsies? Think about where the exponent is.
Mr. Could have been 5 log to base 3 of 9x.
Because you're expanding it, right? You got to put that addition sign there.
Well, how do we know that those 9x are separate?
Because there's a multiplication sign between them. Every time you see multiplication, you throw an addition sign between them. Students, first off, topsies. Here's my statement, though. There's a plus sign. Does it really matter what order these 2 individual logs are in? No. As long as I have 5 log base 3 of x and log base 3 of 9er. Students, if this was the right answer, this is how it would have looked. See how the 5 is to both of them right there? Now I will say this. Which one of these in this purple box could I simplify? Do I know what log base 3 of 9 is, or 5 times log base 3 of x? Allie?
Base 3.
Is?
2.
A deuce. 2 plus 5 times log base 3 of x. And ladies and gentlemen, I think this is about it for the green pen. Students, we've talked a lot about LOG logs, and maybe I should have done more with these natural logs right here, but they have the same properties. What I mean by that is, what really is this 2 here? It's really an exponent, right? The natural log of 15 squared minus the natural log of 75.
ln is the same as log?
Natural log. Natural log. Yep. or as they say it, log natural. Students, real quickly, what number in the natural log am I circling?
10. It's 10. 1.
Nope, none of those. Look at your calculator. What number is closely related to the natural log? Somebody said it. It is the number e. Remember e raised to the x right there on the calculator? Look at the log log on your calculator. Isn't that closely to 10? Right? E and the natural log are the same idea as 10 and the log log. Every natural log has a base e. Students, these two ideas are the same thing. Right here. If I have an log log with a base e, it's really just a natural log. They use the natural log, this abbreviation, because the natural log is the most popular kind of log that people use, especially in determining growth population, population decay, how old bones are out in the world, how things heal over time, like you get a scab or you get a wound on your arm or something like that. Isn't this just the natural log of 225 minus the natural log of 75? Right? 15 squared right here is really just 225. What do I do with the minus sign again, Stephen?
It's like a division sign.
It's the division sign, right? So the natural log of 3. 225 divided by 75 is just 3. Well, you're the one that put it out there. Okay. All right, let's keep going. What do I do first? Do I multiply the 7 and the 5 first, or do I do 5 squared?
5 squared.
5 squared, right? Natural log of 7 plus the natural log of 25.
That's ln 175.
We see a plus sign. We know that we're going to be multiplying them. Students, there's nothing to simplify here with the natural log. The natural logs are really nice because there's no simplification like this right here. If I just put it into the calculator, natural log of 175, it just is going to give me a random decimal there. Okay? Students, right here. Looks like I have the natural log of x squared minus the natural log of 4x squared.
Wait, how is that 4x squared?
Great question. See how this entire thing has to be squared because of that 2 in front? So I have 2x times 2x, which is 4x squared. Students, the natural log of x squared over 4x squared. Isn't this just the same as 1 over 4? All of these natural logs, they have the same base, the base e. This is why I can combine all of them. And the last one, natural log of x to the third plus the natural log of y squared plus the natural log of 5. Now I see a whole bunch of addition with it. I typically would not leave my answer like this. Sorry, trying to get it not blurry. There it is. What would I do? What order would I usually write those in? I wouldn't write the x, then the y, then the number. wouldn't I typically write it this way right here? Just switching the order to make it x third y squared 5? No, I would say 5 x to the third y squared. Are you ready? Are you ready to learn how to use your calculator for these logs? Here's how we're going to do it. Okay? Let's do one that you don't need a calculator for. That way we can verify that we're doing it the right way. Log base 7. Nope. Log base 9 of 729. So let's do this without a calculator and then verify that we're getting the right answer. Allie, first off, what's the answer here? 3. You're right. 9 to what power is 729? Look at it. Yellow sheet back there. 729. It's on the third row, right? Here's how you do this. Whenever you have a logarithmic function that you cannot do in your head, which technically we could do this in our head, you're going to want to use this formula right here. If I have log base of a number with an argument, the base always goes on bottom with the argument on top. In short, the number that's bigger in font size, not bigger in number, but bigger in font size, goes on top. So in my calculator, I am going to type it like this. And if done correctly, you should get the answer 3. Right? Just because it's not a fancy calculator like mine doesn't mean it cannot be done. Log 729, close the parenthesis, divided by the log of 9er. Didn't we get an answer of 3?
Oh my goodness.
Now, this is really helpful because if I have a problem like this, log base 2 of 15. Direct your attention to the pink piece of paper. What row is 15 on?
15,
It goes 2, 4, 8, 16, 30. Wait, is 15 on any of the rows?
It's not on any of them.
It's not. That just means it's not going to be a nice whole number. But really what I'm trying to think is 2 to what power equals 15? Students, try the same thing right here. Could you rewrite it like we did here? Now, the only reason that the LOG works here is because they have the same base. See how right here it's asking for the same base? See how this number right here has the same base? I could have technically used the natural log of 729 divided by the natural log of 9, and I get the same answer, because both of those logs also have the same base. It doesn't matter whether you use the LOG log or the natural log. You get the same answer provided that you do the same log on top and bottom. I personally prefer the natural log. Okay? So right here, I'm going to do the natural log of 15 over the natural log of 2. Natural log of 15 divided by the natural log of 2. But really, does it matter which log I use? Students, this makes sense. Here's why. My answer is 3.9068 isn't 15 really close to 16 back on the pink piece of paper? If my answer was 16, if my argument was 16, wouldn't my answer be 4 on that pink piece of paper? Which means my answer should be really close to 4 right here. Okay? It doesn't matter what you use, LOG or natural log. Here's what I want. I want you students to go ahead and to set these up. Make the fraction for each of them. It doesn't matter whether you use the LOG log or the natural log. Whatever your preferred method is. Go ahead and just set those up. Use that handy dandy calculator. Man, this calculator just becomes more handy by the day. Remember when you found out that it could add fractions and subtract fractions for you? Man, that sure was handy. Yeah, close that parenthesis. Don't leave your parentheses open.
How come leaving the parentheses open make it?
Because it's then going to evaluate the parenthesis first, right? If you close the parenthesis, it has to say, oh, it's just, in this case, 729, right? Think everything else is inside the parenthesis. It's going to try to do all of that first. Does it matter which one goes on top or bottom?
What's the number say? 3.9.
068. Again, students, it doesn't matter if you use the natural log or the LOG log. Make sure that you close the parentheses. Typically, you would round it to 3 decimal places, but obviously, if the directions are asking you to do something a little bit different, please follow those first.